All right, so I think I'm recording. Let's take a look at problem number 26. They've given me a function. I know it's a function because I'm familiar with cubic functions. I know that my parent function for a cubic function looks like this. And I know this negative sign reflects it across the x-axis. What did go up is now going down, and what went down is now going up. And then I know the plus 9 lifts that whole thing up 9 units. So I know that up here, when y is 9, that I've got this cubic function. So it definitely passes the horizontal line test. So it's definitely 1-to-1. That's one way that I can come up and say, yes, this is a 1-to-1 function. Now, if I'm not familiar with my library of functions like I should be, and if I've forgotten these function transformations, which hopefully you haven't, for some reason, if you're not able to picture this graph, you can still arrive at the right answer, because we looked at kind of a rule of thumb. We know that when we were determining whether or not this equation represented y as a function of x, that we focused our attention on the exponents on y. And if there was no absolute value symbols, if there was no plus or minus in the equation, then we looked, and if it was an odd number, it was a function. So when I look at this equation, I know, yes, this is a function. Now, if I apply those same rule of thumbs to the exponent that's on the x variable, I can come up with the same conclusion. If there's no plus or minus symbol, there's no absolute value symbols around x, and the exponent is odd, just like that one was. So I know it's a 1-to-1 function. Any exponent that's going to be even is going to have a graph that kind of looks parabolic, and it's going to fail the horizontal line test. If it fails the horizontal line test, it's not 1-to-1. So we've got two ways to determine that this is a 1-to-1 function. We can visualize the graph and see that it passes the horizontal line test, or by a rule of thumb from previous assignments, we've recognized that if there's no absolute value and no plus or minus symbol, and the exponent on x is odd, and it has to be a function to begin with for that function to get promoted to be a 1-to-1 function. So I can also conclude it's a 1-to-1 function like that. So now they don't give me an equation, but they give me a set of ordered pairs. So maybe the easiest way to determine whether this is a 1-to-1 function or not is to make a mapping. Because if this list is too long, I may not be able to recognize. We used a mapping before to easily determine whether this relation was a function or not. So my domain is the set of x's, the first number of each pair. My range is the set of y values, the second number from each pair. I didn't have any numbers that repeated. If a number did repeat, I would only list it once in the set. Well, this is telling me that 4 is related to -2. And this is telling me that 3 is related to +2. And that 2 is related to 3. And that 5 is related to -3, and 6 is related to 9. So I can see then that this is a function, but I can also see it's a 1-to-1 function, because if I switch the domain and range, then I can see that -2 is related to exactly one value, 4. I can see that +2 is related to one value, 3. That 3 is related to 2. That -3 is related to 5, and 9 is related to 6. So yes, this is a 1-to-1 function, because every element in the range corresponds to exactly one element in the domain. And so if you have any values and the output of the function is the same, then that implies that the input has to be the same if it's a one-to-one function. Maybe that's a little more advanced to think about. Maybe the picture is a better illustrative way for you to think about it. Here we have a graph, and this might be easiest of all to determine whether this is a one-to-one function. Now, I always go through the process of first recognizing that it passes the vertical line test, so yes, this is a function. And then I look and see if it passes a horizontal line test. Well, it fails, so it's not a one-to-one function. I found a horizontal line that intersected my graph in more than one place. So yes, it was a function, but it is not a one-to-one function. Now for the next graph, it passes a vertical line test. Even right here, it passes a vertical line that goes through here, because the solid point means that 2 is related to 5. 2 is not related to -8 because that's a hollow point. That point is not, the point 2 comma -8 is not a point that's on my graph. So yes, this passes a vertical line test, and yes, this graph is a function. Is it a one-to-one function? Well, if we apply the horizontal line test, then I can't find a horizontal line that intersects this graph more than once. So yes, this is a one-to-one function. It passes the horizontal. First, it passed the vertical line test to become a function. It was definitely a function, and then that function gets promoted to be a one-to-one function because it passes the horizontal line test. So yes, this one was a yes, where the last one was no. So now here it's asking me to graph the inverse. So I can make a quick table of values of points that are kind of easy to read off of the graph. So let's call this graph F. I've got -6, 0. I've got -2, +2. I've got 3, 3. And I've got 9, 4. Those are just points that were integer value. I could have picked other points and estimated it, but those were points that were easy to read off of my graph. Well, when I graph my inverse, the x and y, the domain and range, are going to switch. So instead of plotting the point -6, 0, I'm going to plot the point 0, -6, 2, -2, 3, 3, and 4, 9. So this point, and remember also that my new graph is going to be a reflection across the line y equals x, across this 45-degree line. So this -6, 0, when I go to switch the domain and range, becomes 0, -6. Then I've got 2, -2. It's passing through the point here. That's if you're a point on the line of y equals x, when you're reflected across that line, that point still stays there. And then I've got 4, 9, which is up here. So if I just connect the dots, you can see that the red graph that was given is a reflection across the line y equals x for this blue, for this F inverse. And the graphs are related because we switched the domain and range. We switched all of the x and y values. So I'm going to stop there and do the rest on the next video, because I think I went a little bit longer than what I thought I would.